In this podcast, we'll be solving equations involving logarithms. So we're going to look at two different types of equations. In the first type of equation that we're looking at, you're going to notice that there are logarithms on both sides of the equation. This is example 1. In this example, you'll see that there are logs on the left-hand side as well as logs on the right-hand side. You'll also notice that the base matches in all three of our logarithms, and that is, of course, very important. We're going to begin by using some of the properties of logarithms to try to simplify what this logarithm equation looks like. For example, in this case, you'll notice that there is a plus involved between the two logarithms. And we have a property of logarithms that says if you're adding two logarithms together and they have the same base, you can write that as the single log with that base of the product of the two. So I'm going to multiply x by 2x minus 1, and I'm going to go ahead and distribute that through right away. So I'll be multiplying x by 2x minus 1. That's what the property tells me to do. And when you do, you'll get 2x squared minus x. And that whole thing is a logarithm. On the right-hand side, we have the log base 4 of 6. Now, there is a property of logarithms that's referred to as the one-to-one property of logarithm that says if you have logarithms on both sides of an equation and the bases match, the only way the two logarithms could match is if whatever you're taking the log of on the left-hand side matches whatever you're taking the log of on the right-hand side. So the way to solve this would be then to say that 2x squared minus x has to be the same as 6. That's the only way that these things can be equal. And now I just have a regular quadratic equation which I can solve. So we use the one-to-one property of logarithms whenever we have logarithms on both sides of an equation. So you'll see that I just subtracted 6 from both sides so that I can solve this quadratic equation. I'm going to go ahead and factor it now. And with that 6, I'm thinking a 2 here, a 3 here. That would give me a 3x and a 4x. I want the 4 to be negative. As I continue on, this would give me an x of negative 3 halves and an x of 2. Now in this particular problem, I'm going to be rejecting the x of negative 3 halves because placing a negative 3 halves into this logarithm way up here at the beginning would cause me to take the log of a negative number, and we can't do that. So this one automatically is rejected. X equals 2 is going to be just fine here. 2 times 2 minus 1 is also a positive number, so x equals 2 will be our only answer. So that's our first type of problem involving logarithms. It's the type where you have logarithms on both sides. Now let's take a look at our second type of problem. In the second type of example, you'll notice that we have logarithms only on the one side of the equation, not on both sides, so we won't be able to use that one-to-one property. We are, however, going to continue the idea of using our properties of logarithms, one of which is, if I get my pen to work here, says that this 2 can be written as an exponent on the 3, so that we have the log base 16 of 45x minus the log base 16 of 3 squared, or 9, equals 3 halves. And then as we did in our previous example, that one happened to be adding and we multiplied. This is a subtraction, so we'll be dividing. I'll write that as log base 16 of, oops, I missed the x up here before, so I'll rewrite that, of 45x over 9 equals 3 halves. Now we might take that a step further here, and I'm going to write off to the side here, and reduce that fraction, log base 16 of 5x, when you take 45 and divide it by 9, is 3 halves. Now here's where this problem differs from the previous one. In the previous one, it looks like the logs just disappeared because those two inside pieces were going to have to be the same for those to be equal. I can't quite do that here because I don't have logs on this side. So what I do in this problem to undo the logarithm is I write it in exponential form. So the base is 16, the power is 3 halves. That's going to equal 5x. So we undo the logarithm in a little bit different way. 16 to the 3 halves, well 16 to the 1 half is 4, and 4 cubed is 64, so 64 equals 5x. And finally x equals 64 fifths. So how you undo the logarithm is the thing that varies from one type of problem to the next. Here you undo the logarithm because those two things have logs on both sides. Here you have to write it in exponential form.